Hello everyone, welcome to Chemistry. Today we'll be practicing few previous year questions from NEET and JEE on the chapter General Organic Chemistry. So the first question is from NEET 2015. It says the total number of pi bond electron in the following structure. So we have been given this structure and we have to find out how many pi bond electrons are there. So हमें पता है कि अगर एक single bond है then it has one sigma bond. Double bond, in case of double bond, one is a sigma and another one is pi. And in case of triple bond, one is sigma and both of the other are pi bonds. So in this case we have to find out how many pi bond electrons are there. So one pi bond contain 2 pi electrons. So here in this structure we have 1, 2, 3 and 4 pi bonds. So as 1 pi bond is equal to 2 pi electrons and this structure contains 4 pi bonds, so it has 8 pi electrons and the correct answer is option D. Coming to the next question, this question is again from NEET 2015. It says the enolic form of ethyl acetoacetate as shown below has. So we have the enolic form and the keto form of ethyl acetoacetate. Now we can see that this is the keto form because it has the keto bond here, and this is the enol form of ethyl acetoacetate. Now we have to find out how many sigma and pi bonds are there in the enolic form of ethyl acetoacetate. So first it has CH3 has 3 sigma bond. Let me write a complete structure of this enolic form. So CH3 can be written, this CH3, and then carbon which is bonded with one OH, and then it is double bonded with carbon which is bonded with one hydrogen, and single bonded with carbon, double bonded with another oxygen, and there is another oxygen, and CH2 CH3. This is the C2H5 group. I have written it in a complete structure. So this structure, we can write the condensed structure into a complete structure to find out how many sigma and pi bonds are there. So first we have to find out how many sigma bonds are there. So there is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, and another one is between this OH. So this one is 18. So here is total 18 sigma bonds. Now we have to find out how many pi bonds are there. So first there is one pi bond and another pi bond. So here is 2 pi bonds. So the correct option is option C, which says 18 sigma bonds and 2 pi bonds. Now coming to the next question, which is again from NEET 2015, it says which of the following species contains equal number of sigma and pi bonds. So I have to elaborate all the structures, all the 4 structures written here. So first coming to option A, which is CN2. So this structure is carbon triple bonded with nitrogen, carbon triple bonded with nitrogen. Now structure of option B is nitrogen triple bonded with carbon which is bonded with another CH2, so CH2, and another cyanide group on the other side of CH2. Option C has HCO3. So this structure is carbon double bonded with oxygen, double bonded with another oxygen which has a negative charge over itself, and bonded with another OH group. The next is option D, that is XeO4. This structure is xenon on the middle and 4 oxygen double bonded with xenon. Now coming to the sigma and pi bonds in all these structures. So first option A. So it has sigma bonds 1, 2, 3. 3 sigma bonds are there. So I have to write 3 sigma. And let me count how many pi bonds are there. So there are 1, 2, 3, 4. 4 pi bonds. The next is option B. It has 1, 2, 3, 4, 5, 6. 6 sigma bonds. And pi bonds are 1, 2, 3, 4. 4 pi bonds. The next option C has 1, 2, 3, 4. 4 sigma bonds and 1 pi bond. And in case of option D, it has 1, 2, 3, 4. 4 sigma bonds and 1, 2, 3, 4. 4 pi bonds. So the question has asked that which of the following species contain equal number of pi and sigma bond. So in case of option A, it has 3 sigma bond and 4 pi bonds, which are not equal. In case of option B, it has 6 sigma bonds and 4 pi bonds. Again, this is not equal. In case of option C, it has 4 sigma and 1 pi bond. This is also not equal. But only and only case of option D, it has 4 sigma and 4 pi bond, which are equal. So in this question, option D is the right option. The next is the IUPAC name of the compounds. So before writing IUPAC name of any organic compound, we have to learn how to write a IUPAC name of any compound. So the first rule is to select a parent chain. So first rule says that we have to select a parent chain which is the longest carbon chain in the molecule, and then we have to give number to the carbon in the parent chain. So the numbering should be given to the carbon of the parent chain in such a way that any other substitution to the carbon, like this O double bond O groups or this methyl group, these substitutions or functional group should be attached to the lowest count of the carbon. So let me just name this compound. And another important rule is all the substitutions should be put in any IUPAC name as a prefix of the compound, as a prefix of the name. Okay. So the first is numbering of this compound. So I can see that if we select this carbon chain as a parent chain, then it will have total 6 carbon. In any other way, it will have less than 6. So that's why I'll select this one, this chain as the parent chain of this compound. So let me number this compound. So this carbon is numbered as 1, this is 2, this is 3, this is 4, this is 5, and this one is 6. So the next is to find out the name of this compound. So in this case, compound carbon number 3 has a keto group and carbon number 2 has a methyl substitution. So we can write in an alphabetical order the name of the IUPAC name of this compound must be 3 keto, because compound 3 has keto group, and after that 3 keto 2 methyl, 3 keto 2 methyl. Now there must be another question, why 2 methyl is not put before 3 keto, because K comes first in alphabetical order and M's comes after K. So that's why 3 keto is put first. So 3 keto 2 methyl, as the parent chain carbon contain 6 carbons. So after that we'll put hex, and then after that it has one double bond at carbon number 4. So 4 in al. So this compound has a name 3 keto 2 methyl hex 4 in al. So this is the right answer. option D is the right answer in this case. Coming to the next question, which of the nomenclature is not according to the IUPAC system? So, compound A, option A has a IUPAC name 1-bromo-prop-2-ene. So, let me just see whether this compound has the right IUPAC name assigned to it or not. So, I have to first look for the longest carbon chain which will assigned as the parent chain. So, 1, 2, 3, this chain will be the parent chain, and I have assigned this carbon as carbon number 1 because it is attached with a bromine compound. So, the name of this IUPAC name of this compound will be 1-bromo 2-ene, prop-2-ene, because there is 3 carbons, so prop-2-ene. So, I think this name is the correct name, correct IUPAC name of this structure. Coming to option B, so in this case I have to choose the parent chain. So, I guess this a straight chain can be considered as a parent chain because it has largest number carbon attached to it. So, let me just assign numbering to this chain. So, it has 1, 2, 3, 4, 5, 6. Total 6 carbon atom is attached in the parent chain, but in the naming of this IUPAC, name of this compound has put as a pentane. So, it must not include pentane because the longest chain, that is a parent chain, has 6 carbon atoms, so it must be hexane. So, from this only we can cancel out this option. We will not go far into this question. So, option C. So, in this case we have to see whether which one is the longest chain or the parent chain. So, 1, 2, 3, 4, 5, 6, maybe this one. This chain can be the parent chain. Again, in this case the parent chain contain total 6 carbon, but while naming this compound they have named it as a pentane. So, from this only I can cancel out this name. We do not have to dig into the name of the compound when we can simply see that the parent chain is named wrongly. After that, option D. So, in this case the carbon number is 1, 2, 3, 4, 5. Okay. Oh, sorry, 1, 2, 3, 4, 5, 6. So, in this case it is hexanoic acid. This one is right. Now, after that I have to go for the substitution. Okay. So, 1, 2, 3, 4, 5, 6. So, on 5 number carbon there is an oxo group, but in the IUPAC name it has written 4-oxohexanoic acid. So, again this one is not the right option, and option A is the right answer in which the right IUPAC name is assigned to the right structure. So, with this we are coming to question number 6. So, in this case they have asked the correct IUPAC name of this compound. So, in this case this compound has a specific feature because all the other are normal carbon alkane group attached, but there is one functional group, that is a double bond, that is ene group is attached. So, when the functional group, any functional group is attached like double bond, triple bond, acid group, aldehyde group, ketone group or anything, so we have to make sure that these functional groups get the least carbon count. That's why we have to start counting the parent chain from this carbon only, because we have to assign least carbon count to this carbon and this carbon because it has double bond. So, I am assigning 1 to this and now carbon number 2 to this. After that I can see if I consider this carbon 3, 4, 5, 6. So, if I consider this one as a parent chain, it will have 6 carbon. Again 1, 2, then 3, 4, 5, 6. Again, if I consider this one as the parent chain, again this parent chain will contain 6 carbon. I have another option. So, 1, 2, 3, 4, 5, 6. Again, if I choose this carbon, this parent chain, then it will again have 6 carbon atom attached to it. But I will have to choose this chain as the parent chain because it has much more substitution to it, and all the substitution has the least carbon count to it. So let me just write the numbers. So this carbon is named 3 and then 4 and 5 and 6. So after numbering the parent chain, we can see that carbon number 3 has an propyl group attached to it and carbon number 4 has an ethyl group attached to it. So while naming this compound, 4-ethyl should come first because E alphabetically comes first, and after that P comes. E stands for ethyl, which is attached to carbon number 4, and P stands for propyl, which is attached to carbon number 3. So for this IUPAC name of this compound, we have to write 4-ethyl, 3-propyl. As the parent chain contains 6 carbons, so the naming will be 4-ethyl 3-propyl hex 1-ene. So I think option A is the right answer to this question. Okay, so we are left with 2 more questions from IUPAC naming of the organic compounds. So this question, that is question number 7, came in mains 2010. So this question again says, what is the IUPAC name of this compound? Now let me clarify one thing. We have a priority of functional group while naming IUPAC name of the compound. You can find in NCERT books. We can see that double bond has a better priority than triple bond. So in this case, both the double bond and triple bonds are present in a single compound. But while naming this compound, if I start naming this, numbering this compound, this carbon as 1, 2, 3 and 4 and 5, then the proper priority or proper numbering will not be done. So in this case, I have to start numbering this parent chain from this carbon. So this will be 1, 2, 3, 4, 5, because triple bond, this is a functional group, like triple bond has a better priority than a single bond. That's why I have started numbering this compound from this side. Whereas although we know that double bond has a better priority than triple bond, still I am numbering from this side because triple bond has a better priority than single bond. So I am numbering this chain as 1, 2, 3, 4, 5. So the name will be starting from pent. Let me see what will be there after this. So there will be pent 3-ene because there is an ene group attached with carbon number 3. So there will be 3-ene and there will be one triple bond is there which is attached to carbon number 1. So there will be pent 3-ene and 1-ene. Okay, now there is a question why I have not written 1-ene first and then 3-ene, because again the alphabetical order, E comes first and then Y comes in alphabetical order. That's why I have written pent 3-ene 1-ene. Okay, so that's why the correct option in this question will be option number B. Let me know which one you have chosen as the right option and mention it in the comment section. After that, let me come to question number 8, which came in the exam of 2009. So in this case, again there is a double bond and there is a triple bond. Now as I have mentioned earlier, the double bond has a better priority than triple bond. So in this case, we can easily understand from which side I should start numbering the parent chain. So in this case, this carbon will be assigned as 1 and then 2, then 3 and 4. So again, in this case, this compound will have a name, that is 1-butene, because there is double bond that is attached with the carbon number 1. So it will be 1-butene, and after that there is a triple bond which is attached with the carbon number 3. So there will be 3-yne. So 1-butene and then 3-yne. So option C is the right answer in this case. So we have done so many questions on number of sigma bonds, pi bonds, or number of pi bond electrons in any organic compound, and after that we did a lot of questions on IUPAC naming of organic compound. The next is the hybridization. So the first question in this context, that is question number 9, which came in the year of 1991, that says a sp3 hybridized orbital contain 1/4 of s character, 1/2 of s character, 1/3 of s character, or 2/3 of s character. Now in case of sp3 hybridized orbital, we can remember that how much s character contained by any hybridized orbital. We have an easy rule for that, because let me just see, in case of sp3 there is one s orbital and there is 3 p orbital. So we can count 1 plus 3, there are total 4 orbitals. So these 4 orbitals contain 100%. So one orbital will contain 25%, which is 1/4 of 100%. That's right. Now if I see in case of sp2 there is one s and 2 p orbitals. So whole sum there will be 3 orbitals. So in case of sp2, 3 orbital will cover 100%. So one orbital will cover 100 by 3. So in this sp2 there will be 1/3 s character and 2/3 p character. In a similar way, in case of sp3 there will be 1/4 s character and 3/4 p character. So option A is the right option. Now question number 10 is a very easy question, which is also a part of 1991 question paper. So please write the answer. If you know, write the answer in the comment section. So it says the shortest CC bond distance is found in. Now before answering this question, I want to address few things. The first one is in case of single bond and in case of double bond and in case of triple bond. So which bond has a shorter bond distance? First, coming to single bond. So in single bond, both of this atom on the either side are attached with a single bond only. In case of double bond, both this atom on either side are attached with double bond. Now we can easily understand when one bond is attached with 2 of the carbon, the strength is less than when the same two atom is attached by 2 carbon. So in this way we can understand that the bond strength will be highest in case of triple bond, because it can hold both atoms very strongly because of the 3 bonds present. So bond strength will be highest in case of triple bond, and then double bond, and then single bond. This is the bond strength order. The next is bond length. Now bond strength and bond length are inversely proportional. So that's why single bond will have the largest bond length, double bond will have less bond length than single bond, and at last triple bond will have the smallest bond length. Now among these 4 options, we have to see which one has a single bond or double bond or triple bond, and thus we can assign that which one has the shortest CC bond distance. Let me just come to diamond. So in this case of diamond, it is an allotrope of carbon which has carbon-carbon single bond. Next, coming to ethene. Again, in a homologous series, ethene belongs to the alkane series, which has a formula CnH2n plus 2. So in this case as well, we can only see carbon-carbon single bond. In case of benzene, we can see both. So there are 3 carbon-carbon single bond and there will be 3 carbon-carbon double bond. Now coming to acetylene compound looks like this. So in this case we can see that there are triple bond between two carbons. So from this study we can easily say that the bond length or the bond distance will be shortest in case of acetylene. So option D will be the right answer. Thank you everyone. So this is my first video in YouTube, so that's why I need your support, and please write in the comment section if you have any suggestion. I'll be happy to take any suggestion from you guys to improve my video quality or video content. Please write whatever you want to write or any suggestions in this context, and let me know from which chapter you want to do the questions from previous year next, so I can upload the video on that particular chapter and that can help you. Thank you.